Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good day. So I'm Muhammad Faidul Yusuf. Okay, today I would like to share. Okay, I would like to share how to solve the problem of the soil phase diagram. So this is example of the soil phase diagram. Okay, I read the question here. The mass of soil sample having a volume of 0.045 cubic meter is 8.7 kilogram. The moisture content and the specific gravity of the soil solids were determined to be 19% and 2.7 respectively. Calculate the moist density, the dry density, the void ratio, the porosity, and degree of saturation. Okay, to solve this problem, actually you have to know the equation of these parameters. For the moisture density, the equation is equal to total mass divided by total volume, or M divided by V, and the dry density is equal to Ms over V, where Ms is the mass of solid divided by total volume, and the void ratio, symbol is E, equal to Vv, volume of void divided by volume of solid, and the porosity is N, equal to volume of void divided by total volume, and the degree of saturation SR equal to VW divided by V, multiply by 100%, because the unit of degree of saturation is in percentage. So before we solve the problem of soil phase, we have to plot or sketch the phase diagram. So this is the phase diagram. So if you refer to this phase diagram, actually we have air, we have water, and we have solid. So if we have air, water, and solid, means that the soil is unsaturated or partially saturated. Okay, first, from the given question, we know that the mass of moist soil is 0.045, means that the mass of moist soil is 8.7. So the mass of moist soil is the mass of water and the mass of solid, means the total mass. So we know that the total mass here is 8.7. So you have to write here 8.7. Right? And the unit here, we have to use mass. We have to use mass because the given data is in kilogram. We can also use unit weight. We can also use unit weight. When the given data is in Newton or in kilo Newton. And the volume, this is the total volume. Alright, this is the total volume, 0.045. So this is the total volume. So the total volume including Vs, Vw, and Va. So we write here 0.0045. And we also know that the moisture content, so this is the value of moisture content is 90%. So now W equal to 19%. And this is the specific gravity, 2.7, right? So we have to write here GS equal to 2.7, right? So actually we have limited information, okay, to solve the problem, right? So we have to fill in all the blank here. We don't know what is VA, we don't know what is VW, VS, VV, MW, and MS. So how to solve this problem? Okay, the first step, you know that the moisture content is 19%. So what is the equation to calculate the moisture content? So the moisture content equal to mass of water in the soil divided by dry mass or mass of solid. So it is equal to MS divided by MW divided by MS, okay, equal to 19%. So we cannot use the value 19 because the value is in percent. So we have to divide it by 100. So we can get the value here 0.19. So W equal to MW over MS equal to 0.19. So we have to derive or produce an equation. So MW equal to 0.19 MS. Okay, so this is the first equation. Okay, and the second equation, okay, we know that the total mass is the summation of MW and MS, right? So total mass equal to MW plus MS, right? Where M is 8.7, right? So this is the second equation. Now you have to substitute equation 1 to equation number 2. Okay, we know that M equal to 8.7. So 8.7 equal to, so you replace MW here, you replace here, so 0.19 MS plus MS. Now 0.19 plus 1 equal to 1.19 MS equal to 8.7. Okay, from here you can calculate MS equal to 8.7 divided by 1.19. So you get the value here 7.31 kilogram. Okay, so you know that MS equal to 7.31. So you write here, okay, you write here 7.31. And then if you know the total mass is 8.7, you know the mass of solid is 7.31, then you can determine the MW, right? MW equal to M total minus 7.31. So you get the value here 1.39. Okay, 1.39. Okay. Okay, now we move to the left side. we determine the value of VA, VW, VS, and VW. So how to determine? First, okay, the first one, we can use, okay, the specific gravity, okay, to determine the VS. So the basic equation to calculate the specific gravity equal to density of solid divided by density of water, right? So what is the value of density of water? So you can write here density of water equal to 1000 kilogram per cubic meter. Okay, so we have to use rho W equal to 1000 kilogram per cubic meter because the unit in kilogram and cubic meter. You cannot use rho W equal to 9.81, okay, because 9.81 can be used for unit weight of water. If the given data is in kilonewton and the volume is cubic meter, then you can use gamma water equal to 9.81. Okay, this is very important part here. Okay, so GS equal to rho S over rho water, and this is the density. The basic equation for density is M divided by volume, right? Mass over volume. So the density of solid equal to mass of solid divided by volume of solid, right? And then divided by density of water. And this equation become like this if we simplify. So MS over VS rho water. Okay, but actually we want to calculate what is VS, right? So we change the position of VS. So now VS equal to, okay, we move to the left, so it's become 5 PS rho water. Okay, so you have to use this equation to calculate what is the value of S, because you know the GS, you know the MS, and you know the rho water, right? You have to use rho water equal to 1000. Alright, so the value here come MS equal to 7.31, okay, divided by GS is 2.7, and the density of water is 1000. Then you can get the value here is 0.0027. So you write here VS equal to 0.0027. So this is the value of VS. Okay. Okay, then you can calculate also the volume of water, okay, by using the correlation of density of water, okay, because the density of water equal to mass of water divided by volume of water. You want to calculate the volume of water, so you have to move to the left. So volume of water equal to mass of water, okay, divided by density of water. So it's become 1.39 divided by 1000 then you can get the value in 0.0014, 0.0014, and you write here 0.0014 cubic meter. Okay, and then here, okay, you know that the total volume is 0.045, then you know Vs equal to 0.027, then you can calculate the volume of water, Vv, where volume of water equal to V minus Vs. Okay, and then you calculate, and then you get the value 0.0018. And then after that, you can also calculate the volume of air, because you know VA equal to VV minus VW, right? So the value here is 0.0004. Okay, now we complete M. We know the MW, we know the MS, we know the VS, we know the VW, we know the VA, we know the VV, and we know the V. Right? Now complete our phase diagram. Now we can determine or calculate the answer for the parameters. Okay, so now we know here, we know MW, we know the MS, we know VA, we know the VW, we know the VS, we know the VV, and we know the V. Okay, the question asks you about the moist density, dry density, void ratio, porosity, and degree of saturation. So for bulk density, the equation is M over V. So you know that M equal to 8.7 and V equal to 0.045. Then okay, we use this equation, we get 1933 kilogram per cubic meter. For dry density, MS over V, we know that MS 7.31 and V is 0.045. Then we can calculate the dry density equal to 1624 kilogram per cubic meter. And the void ratio, okay, so the void ratio equal to VV over Vs. Okay, we know that VV equal to 0.018 and Vs equal to 0.027. Then the value is 0.67. For porosity, N equal to VV over V, we know that VV is 0.018 and we know that V is 0.045. Then the porosity is 0.4. The degree of saturation, SR, equal to VW over VV. We know that VW equal to 0.014 and VV is 0.018. Then we can calculate the degree of saturation equal to 0.78 or 78%. Very easy if you can use the phase diagram to solve the problem. So I think that's all. Thank you very much. See you again.